Hey everyone, welcome to The Explainer. Right now, deep in the frozen permafrost, there are these microscopic creatures called tardigrades, and they've essentially just paused their biology. They exist in this bizarre state that's neither fully dead nor fully active until the conditions are absolutely perfect. Pretty wild, right? Well, today, we're embarking on this fascinating macro to micro journey to look at the fundamental blueprint of existence itself. We're going to take foundational concepts, literally the very rules of what it means to be alive, and break them down step by step. If you love seeing how the intricate puzzle pieces of our natural world fit together, well, you're in the exact right place. So here's our game plan for today. First, we'll look at living versus non-living things. Second, the key processes of life. Third, habitats, basically the homes of life. And fourth, adaptations for survival. Let's get right into it. I want you to think about this for a second. What's the real difference between a rock and a plant? I mean, at a quick glance, both of them just seem to sit there on the ground, quietly occupying space, right? But if we zoom in to a microscopic level, one of them is simply weathering away, while the other is engaged in this silent, highly complex symphony of cellular activity. And it's that invisible difference that really defines the entire concept of being alive. All right, section 1, living versus non-living, understanding the baseline. Okay, let's dive into this. A rock is essentially a completely static arrangement of minerals. Its atomic structure is totally locked in place. And it's really only going to change if extreme external forces, like wind or water, slowly weather it down over, thousands of years. Now, a plant, on the other hand, is completely dynamic. Even when it's sitting perfectly still, it's actively converting sunlight into chemical energy. It's constantly dividing cells to push its roots deeper into the earth and transporting water straight up against gravity. It's this internal dynamism, this constant active participation in the physical world that absolutely separates a living entity from a non-living object. Moving on to section 2, key processes of life, the ultimate checklist. So for an entity to actually cross that threshold into being truly alive, it has to perform this staggering, invisible checklist. Basically, it ingests fuel for nutrition and then immediately breaks it down through a complex process called respiration to harvest energy. It uses that energy to fuel cellular growth, it actively purges toxic byproducts via excretion, and it reproduces to ensure its genetic line survives. Oh, and it also changes over time and constantly responds to its environment. Just picture a seemingly dead, dry seed sitting on a shelf. It looks entirely static, but the second it detects moisture and warmth, which is a highly tuned response to its environment, it violently kickstarts respiration. It starts burning stored sugars to power explosive cellular growth. So these aren't just dry, boring biological terms, They are continuous, active engines of existence. Which brings us to section 3, habitats, homes of life. Simply put, a habitat is the natural home or environment of an organism. Because, let's face it, life doesn't just float around in a void. Every single dynamic, breathing, growing entity we just talked about is tethered to a very specific physical space. Whether that's a dense, super humid rainforest canopy, a freezing high-altitude mountain peak, or even a hydrothermal vent at the crushing bottom of the ocean. The environment is the absolute non-negotiable stage where this whole biological engine operates. And this brilliantly illustrates how habitats broadly fall into two massive categories. First, we've got our terrestrial habitats. That's the dry land, encompassing everything from rich, loamy forests to incredibly hostile, arid deserts. And then we have aquatic habitats. This is the flowing, oxygen-rich freshwater of rivers and the vast, salty depths of our oceans. Literally every living thing you can possibly think of belongs to one of these massive physical domains. And here's the kicker. The specific domain they belong to dictates entirely different chemical and physical challenges that they just have to solve if they want to survive. And that leads perfectly into section 4, adaptations for survival, nature's magic tricks. The fundamental problem here is that a river presents completely different survival challenges than, say, a desert. Adaptation is the crucial biological tool that organisms use to solve that exact problem. It's defined as the development of highly specific traits over generations that allow living beings to survive and hopefully thrive within their unique environments. Life actively molds to its surroundings in some truly bizarre and, quite frankly, brilliant ways. Just picture this, a fish gliding effortlessly through the water. It is an absolute master of its aquatic habitat. It doesn't just happen to exist in the water. Its entire anatomy is a brilliant biological response to water's density and the total lack of atmospheric oxygen. Those highly specialized fins are intricately shaped to minimize drag and generate targeted thrust. Meanwhile, its gills act as these microscopic, highly efficient filters, pulling dissolved oxygen straight out of the passing current. Without those incredibly precise physical adaptations, there's just no way it could extract what it needs to power all those core life processes we talked about earlier. Now, contrast that mental image with a camel enduring a harsh, totally dry, terrestrial desert habitat. The camel isn't worried about hydrodynamic drag or extracting dissolved oxygen, right? Its primary superpower is managing extreme heat and severe water scarcity. In fact, a camel's oval-shaped red blood cells are a spectacular adaptation. They're specifically shaped to flow smoothly through the bloodstream even when the poor animal is severely dehydrated. And get this, they can uniquely expand to withstand a massive sudden influx of water when the camel finally does get a drink. Every single one of its specific traits is entirely locked to the extreme demands of its home. So the crucial takeaway here is that the mechanics of biology and the physical world are just deeply intertwined. As our sources beautifully point out, the life of living beings depends on their environment, and they mold themselves according to their surroundings. That one profound thought totally bridges the gap. It takes us from the microscopic processes of a single dividing cell all the way up to the massive macro-level ecosystems that we see all around us. So the next time you step outside, take a look at a bird, a squirrel, or even just a simple weed pushing its way up through a crack in the sidewalk. I want you to ask yourself, how have the living beings right around you adapted to their environment? What hidden dynamic traits are they using right this very second to survive in their specific habitat? It's like a giant puzzle waiting to be solved. Keep observing, keep asking questions, and hey, thanks so much for joining me on this explainer.